Central force or conservative force. Next heading is central force. Central force or conservative force. Or conservative force. Conservative force. A central force is conservative force. A central force is conservative force. Conservative force. A central force is conservative force, and a conservative force is the negative gradient of scalar is the negative gradient of scalar negative gradient of scalar potential. Therefore, a central force is negative gradient of scalar potential. It is proved as under. A central force is represented as vector F equal to F R function unit vector R, where is F R is a function of R. Function of R only, and R cap unit vector along vector R. Suppose the force acts on a particle and displaces it through a small distance dr, then the work done by the force. If the force acts on a particle and displaces it through a small distance dr vector, then work done by the force dw equal to vector F dot dr vector. Work done in moving the particle from the position A equal to R1, but work done in moving the particle from the position A equal to R1 to B equal to R2 is given by this is the equation number 1. Work done in moving the particle from the position A equal to R1 and to B equal to R2 is given by work integration of A to B vector F dot dr vector. Vector F dot dr vector equal to A to B integration of A to B vector F R function unit vector R into dr vector equal to A to B integration of A to B F R unit vector R dot dr unit vector R. Then the next is the A to B F R function dr equal to V, capital V, A to B. As Fr is the function of R only, its integral V is also function of R. Then W equal to V, capital V, A to B equal to VB minus VA. Thus, the work done depends only on the value of the integral B, R equal to R1, A, VA, and R equal to R2 at B, VB at the two its point and not on the actual path followed. Hence, a central force is a conservative force. Thus, the work done depends only. The work done depends only. The work done depends only on the values of the integral v at r equal to r1 at a in bracket va and at r equal to r2 at capital B in bracket vb. At the two end points is that at the two end point and not on the actual path followed and not on the actual path followed. Hence, central force is a conservative force. Central force is a conservative force. The negative sign simply indicates that the work done by the conservative force is equal to the corresponding decreases in potential energy. In Cartesian coordinate, vector dr equal to dxi plus dyj plus dzk and vector f equal to fxi plus fyj plus fzk according to relation third but 1 minute. Conservative force has negative gradient of scalar potential. This is and stop this step for sometimes conservative force has a negative gradient of scalar potential. Conservative force as negative gradient of scalar potential. Negative gradient of scalar potential then a to b integration of a to b vector f dot dr vector equal to va minus vb equal to minus v a to b equal to minus integration of a to b dv and minus dv equal to vector f dot dr vector and minus b equal to vector f dot dr vector. This is the equation number third. By the equation number third, according to relation third, minus v equal to integration of vector f dot dr vector. Then the value minus v equal to integration of vector f equal to fxi plus fyj plus fz unit vector k dot vector dr equal to dxi plus dyj plus dz k. Then this value is put in this function. Dr equal to dxi plus dyj plus dz k plus dz k. dz k, we can solve about this function, and the function is minus v equal to fx dx plus fy dy plus f integration fz dz. This is the equation number 4. Partially differentiating v with respect to xyz, we get partially differentiating v with respect to x, y and z, we get minus v equal to minus del v upon del x dx plus del v upon del y dy plus del v upon del z dz. This is the equation number 5. Comparing 4 and 5, we get fx equal to minus del v upon del x. Is that fy equal to minus del v upon del y? Is that fz equal to minus del v upon del z? Then vector f equal to minus del v upon del xi plus del v upon del yj plus del v upon del z k. Then vector f equal to minus I del upon del x plus j del upon del y plus k del upon del z bracket close v. Then vector f equal to minus vector delta v equal to minus grade v. Thus conservative force and expressed as the negative gradient of scalar potential function. Thus a conservative force can be expressed as a negative gradient of scalar potential function v of scalar potential function v. Okay, thank you.